Bon dia, bona tarda. Hola, molt bona tarda. Comencem la sessió d'aquesta tarda, el segon dia del XVIII Congrés. Aleshores, amb una experiència que creiem que pot ser molt interessant. Primer de tot, donar-vos la benvinguda a aquesta sessió plenària de la tarda i donar també la benvinguda al nostre ponent, en Jamie Shiers. En James ens presenta la ponència de 4 dècades d'experiències amb arxius de dades i gestió de documents al Cern. Jamie actualment és el gestor de projectes de preservació de dades emèrit del Cern i aquest és un dels centres d'investigació més importants del món en física i també vol ser o és, de fet, un model de col·laboració científica internacional molt rellevant. És aquesta una institució on han treballat premis Nobel i és una alta qualitat científica. En Jamie té 40 anys d'experiència en tecnologies de la informació, donant suport al programa de física del Cern, concretament el gran col·lisionador d'electrons entre l'any 89 i l'any 2000, i des del 2009 ençà el gran col·lisionador de drons. Ell s'ha centrat en la gestió i accés a les dades, a la preservació de dades a escales de diversos centenars de petabytes i també en la gestió del servei de Worldwide LHC Computing Grid. De fet, una mica aquest servei, perquè tingueu una idea, és una col·laboració global d'uns 170 centres d'informàtica de més de 40 països que entre ells uneixen infraestructures de xarxa nacionals i internacionals amb la missió de proveir recursos informàtics globals per emmagatzemar, distribuir i actualitzar els aproximadament 50-70 petabytes de dades anuals que està generant el gran col·lisionador de drons. Així mateix, volia destacar, o crec que és pertinent destacar també que en Jamie ha participat molt activament en activitats d'estandardització, crec que és un aspecte interessant, en aquesta matèria i sobretot pensant en comitès d'abast internacional com serien els mateixos comitès de la ISO o de l'Institut d'Enginyers Elèctrics i Electrònics, la IEE, Institut d'Enginyers Elèctrics i Electrònics. Són dues institucions d'estandardització molt rellevants. Bé, simplement només perquè tingueu aquesta visió, creiem que és un component de prestigi i també és una experiència que crec que ens pot ser d'interès. Ja passo la paraula al ponent. Moltes gràcies.
Okay, thank you very much. Thank you for taking the time to listen to me. So as the title shows, handling all sorts of data. This is related to 2 main projects at Cern that I will describe very briefly. I'm afraid I'm going to use some words that might not be familiar to you in your everyday life, such as lepton and hadron, but don't worry, they don't really matter. I think it's an important point that this is a retrospective viewpoint, so it really covers what happened as opposed to what was planned. And I think that's important because often when you speak to people about archiving or indeed any services, they give the impression that everything is solved, is perfect. But if you look back, that isn't always the case. So in particular, I would like to emphasize that this is not a description of a single lab-wide coherent long-term project covering all types of archive material that I will mention. Nor in fact is it a presentation on the activities that I've held over the last, let's say, 8 years. So there have, of course, and still are many projects in these areas. But there's a problem that I want to emphasize, and as these cover only the individual projects cover only a fraction of the whole space, and definitely not the whole time. 4 decades is a long time in terms of IT services. You tend to get holes and gaps, and this has led to unrecoverable loss of information, which is more than sad. Of course, I'm not going to go over the fact that Cern is where the web was born. This is once again to remind you that this is not just a glowing report of explain yet another reason why we needed the web. Of course, the web has grown way beyond what it was originally foreseen to be a means of sharing information. But even if you have the best tools, the best policies, and the best standards, which are in any case constantly evolving, particularly over a period of decades, you need to apply them. And what we have found is often, even if there are policies in place, they're not universally adhered to, and that again leads to problems. So fortunately, thanks to some of the background work that led to this presentation, some corrective actions are being taken, but still we have already lost information. So some quick background to Cern, how we plan these projects that last many decades, which led to this talk, and further reading if you are so brave. You probably know some of this, so CERN, its full name is the European Organization for Nuclear Research. It's currently the world's largest particle physics research center. There are others. There were numerous sites in the US, that they're less now, in Canada, in China, in Russia. And in fact, many countries had their own centers. But as things have got larger, budgets have increased, it's tend to be concentrated in fewer and fewer centers. So for most of the period I'm talking about, there were about 20 European countries funding CERN. The annual budget was about 1 billion Swiss francs, or 630 million euros at the time, and something like 2,500 staff, and more than twice that number of users who are researchers from all over the world. We studied these esoteric the elements, and the flagship projects I want to mention are LEP, which ran from 1989 to 2000, the Large Electron-Positron Collider, and then roughly a decade later, and still in operation, the Large Hadron Colliders. And future colliders are under discussion, not necessarily circular, although that is one possibility, and these might enter operation maybe 2 decades from now, and might run until the end of this century, so to approximately the 90s. So here you can see schematically the main machines at CERN. LEP and the LHC both share the same tunnel, not simultaneously in time, 27 kilometers in circumference and roughly 100 meters underground. And you can see where we are, just outside Geneva, north of Lake Geneva, Lac Le Mans. And you could probably see roughly the airport in that photograph. This diagrammatically is what we study. Don't worry, I'm not going to go into this in any detail, nor am I going to ask you questions on it later. But these gives you an idea of the fundamental things that we are trying to understand to get a better picture of how the universe works, basically. So I'm only going to go through this slide in very little detail, basically to mention that the most recent update of our strategy, we update the strategy approximately every 7 years. This was done last year in 2020, and already this is a multi-year process. And this involves hundreds of physicists, not just from Europe, but also from around the world. And what we try and do is make sure the strategy in Europe is consistent with and complementary with strategies in other areas of the world, in the US, in China, in Japan, and so forth. And it's adopted at the level of the Cern Council, where all of the countries, including Spain, that finance Cern, have a say and have a vote and agree or disagree with what the strategy is. So as I just said, the most recent update was approved last year, and this followed an open symposium that I was fortunate enough to attend in Granada the previous year. And not surprisingly, one of the main elements is to continue to exploit the current machines, particularly as the Large Hadron Collider, the LHC, has at least another 2 decades of useful life ahead of it. But also to look forward to future decades. And what I'm going to concentrate on are these future circular colliders, which in many ways would be natural successors to the two that I have worked on, the LHC and LEP. And you can see a timeline here. And again, I don't want to go into detail. There is a yellow box which covers the machines I want to mention, which are an electron-positron circular collider and a hadron circular collider. That's FCC-EE and FCC-HH. And as you can see, the timeline for these, including R&D, construction of the tunnel, building the detectors and so forth, starts now and goes until the end of the century. So these are very long-term projects, and even the youngest person starting today in 2021 is unlikely to be working in 2099. Maybe their children or grandchildren will be. So to summarize these rather busy slides, the vision can be summarized in these 3 statements. The vision is to prepare a Higgs factory, so that was one of the great discoveries of the current machine, the LHC. And going beyond that, another Hadron Collider, which would be more a discovery machine. And I'm sorry, these are a bit technical, but the big advantage of an electron-positron, a lepton collider, is they're much cleaner and you can have much more precision because electrons and positrons are themselves fundamental particles, whereas hadrons are not. Hadrons, we collide, tend to be nuclei like the proton, the nucleus of hydrogen, which is composite. It's composed of quarks and gluons. So when you collide protons, you're in fact colliding bags of subparticles, which is not the case with electrons and positrons, which are elementary point-like particles. I hope you got that. Okay, so now, or when we had the update, the strategy update, we were approximately halfway between the end of data taking at LEP and the possible start of data taking at a future E+ E- circular collider, which is given with, I would think, amazing precision as 2039. And just as LEP, when it took data at 2 energies, first producing Z0s, a force-carrying particle, and then W+ pairs, and then tried to find the Higgs, but it didn't reach it. It didn't have sufficient energy. But it would have much, much greater statistics. So 10 to the 5 times approximately, depending on which energy. So it would have much more precision and possibility to investigate these existing particles in more detail, not just the Z and the W, but also the Higgs itself, and also top quark and anti-top pairs. Okay, I hope that's enough for technical stuff. So where we are today is the data from the 4 experiments that ran at LEP, 1989 to 2000. They're still available and they're still actually used for scientific purposes, by which I mean publications in peer-reviewed journals and for getting PhDs. The volume of data to us looking back from now at about 100 terabytes per experiment might look completely trivial. But of course, this was not the case in the 90s when the data was being acquired. And at the beginning of data taking, there was no managed storage. So the experiments were on their own, basically. The only thing that we offered them was a central place where they could buy their tapes, but they had to look after them completely themselves. But in fact, even though the scientific data dominates by far, it's not sufficient. You also need software, obviously, and this might be millions of lines of code, but you need a lot of information about the detector itself. You need documentation, you need training, all sorts of material. And this is something that I have come to realize through this exercise it is not enough just to preserve one sort of data. You have to preserve all of them, and there have to be consistent links between the different data types. And as the services that you are using almost certainly evolve on different timescales, then you have problems for how you handle this migration. Particularly as, if you look back, the people who wrote that software have almost certainly all retired. The documentation, how was that written? It almost certainly was done in a very different way to how it's done today. However, if we build these new machines, if we get the funding to build these new machines, there will be a great deal of interest in this existing data to design the machines, to prepare the detectors, and so forth. So that was what I got out of the Granada Symposium, is that we really had to try and document as thoroughly what happened in this great project lasting several decades. And looking back, it's clear that I get to this in a minute, sorry, I've lost my thread a little bit. The way we prepared documents and other material in the 80s was completely different to now. If you gave a talk in the 80s or 90s, you almost certainly didn't use a tool such as PowerPoint. You probably handwrote the slides. And so where are those slides now? Maybe you stored them on your shelf, but then when you moved office or left, they were all lost. Could anyone read them? Would they be legible after this at the time? So when we were planning the LEP machine, so this was from already the late 1970s and the early 80s, there was no formal process such as what we had today. And computing this was long before PCs. We were in the mainframe era. So forget something like WYSIWYG text processing. Everything was done in batch. Some planning documents still exist on paper. Some of them were probably typed on an IBM Golf Ball typewriter, if you're familiar with these. Some were printed on computer printout. Fortunately, we went through an exercise a few years ago to scan as many of these as possible. But they're just scanned, they haven't been OCR'd, so they're rather unwieldy to process. If we get back to the source files for any documents that were prepared with a text processing system, these are almost certainly long since lost in the many mainframe migrations. And even if we had them, would we have the programs to process them? And this is a question which I think is still open, is who worries about long-term archiving and conversion of these files? Now, many people will tell you they will automatically convert today's documents from Word or PDF or whatever. But again, over many decades, are these going to be persistent? Will people still be using Word and PDF in 2095? Who knows? And again, there's no reference number. Now people are used to having a DOI for documents. This is something that people didn't dream of then, nor any clue how they were marked up. Just a reminder, okay, these are mainframes. This is how you don't choose colors by taking a vote, because our cray was chosen to be yellow and blue because these were the winner and the runner-up of colors, probably the ugliest cray in history. So computing for lab was it never stopped changing. We started, as I said, with mainframes. We had, I think, 3 mainframe migrations even before we'd started taking data. And then what happened is we had workstations and high-end workstations hitting us, PCs, and so all the time we were migrating all elements of the computing infrastructure. So even when our famous colleague, Sir Timothy Berners-Lee, was making his proposals for the web, there were competing markup languages. There was SGML itself. Digital Equipment Corporation had their own version, SDML. There was TeX, there was LaTeX, and there was no automatic conversion between these. It was often a painful process. And even today, people make very simple errors. I mean, this is a real one that I've seen quite often, is people who don't know and don't check. Instead of writing 10 to the power of 18, this is written as 1018, which is a completely different number, particularly if it's credited to or debited from your bank account. And looking back at the documents, it's hard to imagine how we could even work then. We didn't have email. Even by the early 90s, if you had a Cern business card, it had the Cern telex address on it. If you've never used a telex, you're lucky. When something like fax arrived, this was a game changer because it was so much more immediate than telex. You could write your message yourself and send it, whereas telexes were done by dedicated operators who very often misinterpreted what they had to send, because they also were not experts in leptons and protons and hadrons and all this nonsense. So to summarize the 1980s, there was far from any standardization on text processing, no consistent archiving or even any archiving of documents. The standard at that time is you went to the secretariat of the department or division who produced them, but those secretariats have long since disappeared, and almost certainly all the files were cleared out and probably just thrown in the bin. And if paper copies have survived, they were due to individuals such as myself who kept them in their office or eventually took them home. So I think we have to accept that the vast bulk of documentation, software, and even scientific data prior to the startup of LEP has simply been lost. Very sad. And as I mentioned, this was one of the first steps going away from mainframes to these high-end workstations, where you were going from machines that cost tens of millions of dollars just to tens of thousands, but often had the same single stream processing power. They were much less efficient at handling multiple jobs, but for single stream, they were very good. Okay, so far this was covering a lot of the planning, where this was a series of paper documents. The execution and ongoing optimization for the LAP and also the LHC is covered in a series of around the world. Now, they would hope that all these conference proceedings would still be available, and we could look back at those documents and try and find out what happened. And unfortunately, this is also not the case. In many cases, there are papers missing. I will give some examples so you can see. So this is an example. I mean, I chose deliberately someone, an author from one of the main centers in Spain, in Barcelona. And you can see, well, I don't know, this has been scanned. It's far from perfect, but you can still read it. There are other documents that are, whoever did the scanning didn't even bother to check that what they scanned was of any use. There are other examples, such as this one, where it looks like it's been redacted. I mean, what's this great big black marker at the top? Was there something secret there? I mean, who knows? It certainly doesn't look like a conference paper. And what I found myself is even when you have a document such as this one, which is rather poor, if you actually use even a public domain OCR tool and convert it to PDF or whatever, it manages to actually improve greatly the resolution, as long as it doesn't make mistakes. Some of them just make complete garbage. So you have to have someone in the loop who can at least proofread the converted document to make sure it hasn't completely corrupted it in the process. Okay, I don't have that many slides left, but I'll just go through those. So what I'd like to see after all of this exercise is that we are much more consistent in how we handle all of the data. So for example, in our discipline, I think in the electronic libraries that exist, there should be something very simple like a collection that covers all of these conferences. And there's others, that there's computing schools, there's accelerator schools. And I think it would be nice if the agendas, the talks and papers would all be in machine readable format. So those produced from legacy conferences should be at least OCR'd, but today is where the papers are born digital, they should be directly captured. And this, amazingly, to me, still doesn't seem to be the case. I've had papers that I've written only a few years ago, which have appeared by some unknown mechanism in the Cern digital repository, where they looked as if they were printed on the lowest quality printer in the entire world, maybe faxed around the world and scanned. And seeing as I had uploaded the source and the PDF, I think it will be important to understand how these talks and papers are entered into the system. I also think it would be wise. So normally when you attend a conference, there are strict guidelines on how you produce your documents and presentation. And I think these templates and any other obvious metadata should also be captured. And nowadays this would mean DOIs and ORCIDs, but obviously in the future this will evolve, and there may be some better system. It's very unclear how you can then reverse engineer the previous conferences. But at least in our field, I'm afraid to say that none of the above is currently true. This might not be surprising, as it's not our main area of work. Our main area of work is obviously the scientific data and the results. But still, it's a very important element of that. If someone wants to go back and try and understand how we produce those results in detail, they will want to know these things. And if they can't find them, then I suspect some of the whole chain will be called into question. So this comes to the whole question of what today, well, for probably 2 decades, have been called trustworthy digital repositories. And this led to my change of activity. My previous work in supporting the offline computing of lab, obviously with many others, and the LHC, when we had this momentous occasion when the announcement of the Higgs discovery was made, it was clear that my work on the LHC service, computing service, was no longer needed, whereas there were still problems, big problems around how we handle data preservation in HEP. So this has led to discussions on standards where people don't agree. But in preparing a self-assessment using, in fact, the most rigorous of these assessments, ISO 16363, I realized and have tried to argue since that you cannot separate one sort of data from the others. If you have the data but you have no software, or you have no documentation, or you have no training or guideline how to use the software, you're simply lost. And so you might have your 500 petabytes of data, but you can't do anything with it. And back to what I was saying earlier, is even if you have agreed, so even if you have got a formal certification, this has to be adopted across the organization. And at a place like Cern, this is even more complicated. So on the one hand, it is probably easier for a large organization such as Cern, where we have over 2,000 people, to find the resources, human and otherwise, to handle data preservation. But it's probably easier on the other hand for a small organization to reach global agreement. Today's collaborations who work on the LHC can be several thousand, 3,000 for Atlas. And the community is about 20,000 people around the world. So how can you actually get everyone to not only agree to this, but also to sign up to it? If you have a weak link somewhere, then you're going to have incomplete archive record and possibly data loss. So how can we actually agree this in theory, and how can we then implement it in practice? So I'm coming up to the end now. So again, a summary of the recent strategy update is that we should investigate the financial and technical aspects of building a new collider. You can see schematically, LEP LHC has gone from being a big circle to a small circle, and the numerous rings in the upper plot show the possible tracks of the tunnel. So if you build in this tunnel 100 kilometers in circumference and 100 meters or more underground, you have to be very careful about the geology and to optimize it for the whole area. It's quite complicated. There might be, there certainly will be areas where you have underground water sources, but there might be other problems. There might be types of rock that are very, very hard to drill through, or others that are unstable and will not support a tunnel, and so forth. Anyway, so clearly we are only at the first steps of this next possible machine, and it will be many, many years before a decision whether we should actually build it or not will happen, and this might happen at the end of this decade, or maybe even sometime in the next. So in summary, Europe is looking forward to next generation machines that will take us out until the end of this century. And even though it was not originally foreseen, thankfully, virtually all of the data and much else from both the predecessor machines, LEP and the LHC, are both still available and usable. Preparing this talk has helped highlight some of the problem areas, and thankfully some work is underway to try and fill the gaps and improve things. But one point I keep reminding people is you should not underestimate migrations. They will always be needed. We won't be using x86 and I don't know what in 70 years' time. Who knows what we'll be using? And probably some of the original authors of the software, the documents, what have you, will no longer be available, and so they won't be there to guide you in migration of the different records. So as this statement has been attributed to many people, in theory, there's no difference between theory and practice, but in practice there is. And that, I think, is an important message about the whole field of archiving over decades. So if you're brave enough to want to read any more, you can read some papers about these two machines, and you can read the full European strategy for particle physics. I'm afraid all of these are English, they have not been translated. Thank you for your attention. I hope there was at least something of interest there for you.
Hola, bona tarda. Si us sembla bé, hem tingut algunes preguntes pel Jamie. Intentarem agrupar-les en dos, com en dos blocs. Aviam si breument ens pots donar una mica de resposta o de pista en el que plantegen els companys. El primer grup seria unes preguntes fetes pel Joan Reglà i l'Alan Capellades, bàsicament orientades en el moment que comentaves la pèrdua de documentació de projectes o dificultat per recuperar software, no? Que heu tingut sobretot fins l'any 1989, no? Aleshores, serien com dues preguntes una miqueta, una concreta, que si heu considerat solucions com l'emulació que defensa Jeff Rodenberg com a manera de renderitzar, representar aquests documents en el software originari, aquell que heu emulat, si seria una tècnica, es parla després de migracions de la informació. Això seria una aproximació, i l'altra, d'alguna forma, era si podies posar algun exemple d'aquestes pèrdues, essencialment perquè ens trobem que, com a mínim en el nostre entorn, la informació científica no és gaire accessible en aquest tipus d'informació i bé, aleshores per anar sensibilitzant també en els nostres responsables polítics. Aquest seria el primer conjunt, no? Si heu pensat en emular i algun exemple. Després tindrem una altra pregunta.
Okay, should I speak now? I think there are probably three different areas. I'll start with the software one. So today there are people who are looking quite successfully at using virtual machines and emulation to keep software alive for, say, plus or minus 5 years. And how long that will work for, I don't know. But part of the problem going back the decades that I was mentioning is the hardware was so different. Today, what you're basically emulating is some sort of x86 with maybe a different version of Linux or Unix. This isn't the same as trying to emulate a mainframe where the instruction set was completely different. The floating point operations were different and proprietary between vendors. But what I already proposed in the early 90s was that every time we made a software release, we would at least archive that version. So you wouldn't have all the individual point releases and the bug fixes, but at least you would have some baseline versions. And unfortunately, that's not what happened. And what happened was we had three versions. We had old, the current, and the new version that was being worked on. And when there was a new release, the old directory tree was simply deleted. And so that meant eventually that some complete packages were lost, and maybe they're on some archive tape, but then they're written in a language that no longer exists. These were not just written mainly in Fortran, but the Fortran standard has changed, but they were written using some preprocessor directives, and that those programs don't exist either, and they were written for hardware that no longer exists. So it starts to get very difficult. There is work about software presentation, and in the extra reading, I wrote a paper on that a few years back. It doesn't really give solutions, but it documents what happened. For the documentation itself, I think there's not really any excuse, because even if we didn't capture the LaTeX files or the SGML files, the volume was not so significant that we couldn't have at least scanned an OCR, the printed version. I think it was probably, this fell in the gap between born analog and born digital. And there are debates about that, of which will last longer. Some people claim that actually born analog will last longer because we have the paper records. With born digital, there's so many migrations and so forth. When it gets to the data itself, there, at the startup of LAP, we had about 1 million tapes, and we simply didn't have the storage for those tapes. So if you take those tapes and you put them in the basement, and you bring them back 1 year later, 10 years later, whatever, even if you have a drive that still supports those tapes, you probably won't be able to read them. They have to be kept in very special conditions. And today's tapes are even more demanding. I forget the exact specification, but they have to be kept in clean room conditions. So if you take them out of the clean room and put them somewhere, you don't want to put them back into the robot, because you'll probably damage the robot with all the dust and other particles. So there are many different problems. There are potential solutions, but again, one element of my talk is the fact you really have to have some coordination between projects addressing the whole field. If you solve one and not the others, you end up still with a problem. So I hope that's answered some of these questions.
Moltes gràcies. No sé si tinc temps, l'organització, per una pregunta més.
Endavant, Lluís.
Vale, gràcies, sí. Bé, Jamie, també potser és que vinculat amb això que estaves comentant sobre la capacitat d'emmagatzemar dades i recuperar-les, o informació. També hi ha dues preguntes molt enfocades en aquest punt, que era el que també en la teva ponència has destacat i que ha cridat l'atenció. L'Hilde Rojas i el Paco Fernández demanen una miqueta, si pots, de fet ja ho has fet força, és a dir, com garantiu la conservació d'aquesta ingent quantitat d'informació? És a dir, ja has parlat també d'aquests repositoris que esteu usant, és a dir, que, per tant, entenem que teniu una gran capacitat d'emmagatzematge, però no només d'emmagatzematge, sinó de conservar el context de tota aquesta informació que teniu. Això seria una qüestió potser més material i que ja ho has apuntat, però també, sobretot, si teniu algun mètode, alguna metodologia per avaluar, per si feu selecció dels materials o bé de la informació o bé la conserveu tota. És a dir, no sé si en aquesta gran quantitat d'informació la conserveu tota en brut, els científics o altres disciplines hi fan alguna mena de selecció?
Okay, so I think if you look at these ISO standards that I mentioned, there's an awful lot of theory and practice and experience out there that can give you guidance. That doesn't give a complete answer. So the people who maintain those ISO standards, they're in fact the space community. One of them said recently that maybe Cern does what's called bit preservation better than anyone in the world. And that is the very large volumes of data that we store on tape. So there we have practices where regularly we check the complete integrity of the data. But this is something that is probably only relevant for people who have, let's say, above 100 terabytes of data. If you have less than that, you probably want a different technique. And there, a technique that is still proposed by Stanford, by their library, is that you simply have lots of copies, preferably geographically separated and maybe in different systems. and that will help to protect against all sorts of disasters. In the worldwide LHC computing grid, where we have one main center at Cern and around 10 around the world, we have seen all possible disasters. We've seen typhoons and floods and earthquakes and fire. We've had uninterruptible power supplies bursting into flames and destroying a data center. So actually having more than one copy is something that I do with my private data. I have as many copies as possible. But you still have to check the data periodically in some way. And again, this depends on the type of data. If it's software, it's no good looking at it. You have to make sure that it compiles and you can verify that it's producing results you consider acceptable. If it's documentation, one thing we do is we make open data releases, and the documentation is tested by non-expert users, and if they can actually do what they're supposed to do, we consider that a success. But in total, this is a pretty complex area, and one where I think we can only win by collaborating. The more we collaborate, the better. No one has a perfect answer, and sharing ideas and experience is I think, the best solution.
Moltes gràcies. Jo no sé si hi ha alguna pregunta més que tingueu en el foro. Veig que encara no, tenim encara alguns minuts, si us sembla. No sé. En principi, no sé. Veig que no hi ha més qüestions obertes. Sí, ara ens entra una, la Pepita Reventós, de la Universitat de Lleida. Bé, la Pepita Reventós, de l'Arxiu de la Universitat de Lleida, ella ens pregunta, Jamie, ben com ho veus, si amb el que acabes d'exposar es podria considerar que la tecnologia blockchain podria ser un recurs en aquest entorn o no, o pot ser un límit. No sé, depèn de com gestioneu.
I think it's certainly a potential solution to at least part of the problem. I don't think there's any solution to all of the problem. One thing I perhaps should have stressed, I mentioned about this question of people buying into the policy. We certainly have people at Cern who don't agree that you should preserve information, and they actually work actively to delete it. And I have tried to, so some of the data from the lab era, people are suggesting that when they migrate it, they delete everything that they consider to be not interesting. But how can they possibly know what is interesting and what is not interesting, and what might be interesting in the future? One thing's for sure, if you delete it, then there is no future. And because we are talking in this case about, I suspect, maybe a few terabytes, I find the whole discussion ridiculous. So obviously there are cases where the amount of data is so large that financial and other considerations come into play. But for example, for our data, for LEP now, where it's 100 terabytes per experiment, to try and separate that out from the rest of the data, from the LHC data, would cost more than simply continuing to preserve it. You know, it's less than 1 per mil, and so to weed that out, you'd probably make mistakes, and that wouldn't help at all.
Sí, I suposem que vosaltres no teniu l'afegit del Reglament Europeu de Protecció de Dades, no? Que en l'administració normal ens obliga a eliminar informacions personals. Vull dir que, per tant, estaríem, entenc, en un entorn de conservació de dades a llarg termini, no? Tot i així, no us heu plantejat, i veient l'enfocament que fas de costos, disposar d'alguna mena de comitè, comissió científica que pugui acabar depurant aquestes dades o inclús l'ús ètic d'aquestes dades. És a dir, un enfocament més col·legiat compartit dins del Cern per l'ús d'aquesta informació. O sigui, la governança, en aquest sentit, d'aquesta informació.
Okay, so let me first mention GDPR. So this is something that is relatively recent, and yes, it does conflict with data preservation, and people have given examples. You might have some network of data and papers and results and so forth, all linked together. And as you say, some person might say, no, I want my data to be deleted, and so what happens to the network then? So there are certainly conflicts, and there are conflicts in the principle that you shouldn't preserve data just in the case that you might need it. I don't think we have a solution. In terms of a discipline-wide committee, whatever, we do have such a committee. This is this DPHEP organization, but this is so complicated that we discuss and we write reports, but we don't have a global solution. We don't have an answer. We can describe and share best practice, and that evolves with time. And again, we try and make sure that we're benefiting from all the experience outside our field, where also there's an awful lot of work. There's a statement I don't think I included, is there's no such thing as preserved data. There's only data that is being preserved. So if it's not active, it's simply dead, and sooner or later something will happen to make it unusable. So some low level of constant effort is required.
Molt bé, gràcies. Simplement una reflexió final que ens feia un company, i bé, arrel d'això que comentaves, i en principi ja estaríem, si veieu que el cost que suposa aquesta conservació serà sostenible, no?, en el futur, vull dir, perquè és incremental. Podrem o podrà el Cern sostenir aquesta despesa? Era una mica el dubte que sempre queda en aquests sistemes, i si ens ho voleu resoldre, i crec que seria l'última qüestió que li trasllado.
So I can only answer for our discipline, where we use fairly standard ways of measuring the value of data, such as papers and PhDs. And then we can see that even decades after the data was taken, the value greatly exceeds the cost. Now, you can do an exercise on your data, and you might not come to the same conclusion, but our data obviously cost a great deal to acquire, if you include all the planning, the construction, and everything like that. And now we estimate it's a fraction of a person. So what we see is that as time goes on, person costs dominate and hardware costs tend to zero. It might take a very long time to tend to zero, but that's what happens. And the person costs tend to a fraction, maybe 10–20% of an FTE. So of course there are projects where you cannot possibly imagine to invest 10–20% of an FTE even a few years after the end of the project. But in our lucky case, where we have a community of 20,000, to say you can't invest 20% of an FTE is simply not believable, particularly if there is ongoing scientific value. And we can say that for our data probably till the end of this century. After that, I won't be here to answer the question.
Suposo que molts tampoc. Moltes gràcies, Jamie. Molt interessant aquesta reflexió final i reagrair-te aquesta sessió i també a tothom l'estada. Crec que ja fins aquí. Moltes gràcies.
GD es el componente de la plataforma G11 que facilita el proceso de gestión documental y archivo al resto de herramientas de la organización. Podrás gestionar las necesidades de cualquier tipo de archivo, desde el archivo físico clásico hasta el electrónico o híbrido si lo necesitas. Se adapta a cualquier política de gestión documental, pudiendo configurar tanto metadatos de normativas y estándares de descripción archivística existentes como metadatos propios. Comenzaremos con la definición de las fases de archivo que necesitemos gestionar, estableciendo por cada una de ellas los posibles depósitos, pudiendo ser físicos o electrónicos. Los depósitos físicos son completamente personalizables, tanto en niveles de almacenaje como en unidades de instalación. Define los diferentes fondos documentales, configurando cuadros de clasificación, describiendo las diferentes series documentales y estableciendo sus correspondientes tablas de valoración. Podrás localizar y acceder a las series documentales navegando de forma gráfica a través de una estructura en árbol o utilizando el buscador a partir de cualquiera de sus descriptores. Para describir la documentación, podrás definir esquemas de metadatos de cada entidad y sus relaciones, personalizando los formularios de introducción o búsqueda de información, así como su presentación al recuperarla. Podrás describir las actividades y asociarlas a series del cuadro de clasificación, que pueden tener a su vez asociadas las regulaciones, disposiciones o normativas que aportarán otro nivel de descripción al expediente, cuya información será producida y custodiada por diferentes tipos de agentes. Una vez adaptado a la política de gestión documental, el sistema recibe la documentación desde las diferentes herramientas para gestionar su ciclo de vida. En la fase de captura, los expedientes y documentos ingresan en el sistema. A partir de este momento, se van vinculando los diferentes agentes que intervienen. Se le asociarán identificadores únicos y una primera descripción mínima. Y dado que los expedientes son el reflejo de un procedimiento o actividad, GD permite su clasificación automática en la serie documental. Conforme avanza la tramitación en el resto de herramientas para dar respuesta a diferentes actuaciones administrativas, se incorpora nueva documentación, se actualizan los metadatos o se vinculan nuevos agentes. Vamos completando así la descripción del expediente a lo largo de las diferentes fases. A partir de la información almacenada en el sistema de gestión documental y archivo, podrás localizar fácilmente la documentación mediante diferentes opciones de búsqueda. Sencilla, por un término relativo a cualquier descriptor, o incluso búsquedas más complejas, combinando filtros de diferentes campos o incluso de diferentes entidades relacionadas. Tras lanzar la búsqueda, recibirás un listado con los recursos que cumplen los criterios establecidos, permitiendo acceder al detalle de cualquiera de ellos. Si es una búsqueda frecuente, recuerda guardarla con los filtros preestablecidos para relanzarla en futuras ocasiones de forma rápida. Finalizada la tramitación del expediente, se habrá llegado a su versión definitiva. Las diferentes herramientas ya pueden solicitar al sistema el cierre del mismo, produciéndose el foliado y la generación del índice electrónico. A partir de las tablas de valoración, tendrás la posibilidad de configurar las transferencias al archivo para su conservación definitiva, así como de seleccionar o eliminar tanto el expediente físico como el electrónico. Para todos estos procesos dispones de múltiples asistentes donde generar las relaciones de entrega de transferencia, propuestas de eliminación o muestreo de los expedientes, entre otras. Por otro lado, si te preocupan los problemas de obsolescencia digital, ten en cuenta que el sistema contempla procesos de transformación de formatos para evitarla, garantizando su accesibilidad a largo plazo. esto no es todo. A partir de la información almacenada podrás disponer de un módulo de difusión web de las colecciones de archivo, generar estadísticas y cuadros de mandos, gestionar la cartera de servicios, controlar el espacio de los depósitos físicos, consultar el calendario de retención o integrar herramientas de vocabularios controlados. Y siempre con la ventaja de utilizar software de fuentes abiertas. ¿Quieres saber más? Hablemos.
¿Estás cansada? Todos estamos cansados de ver estas situaciones de pobreza, hambre, cambio climático y no obtener respuesta. El planeta está agotado y hay que pasar a la acción. La Agenda 2030 nace para afrontar esta complejidad y disponer de un marco para actuar todos juntos a partir de unos objetivos comunes. T-Systems ha desarrollado un sistema de indicadores que ayuda a las administraciones locales a cumplir con sus compromisos de sostenibilidad de la Agenda 2030, alineados con el Plan de Acción Municipal. Esta iniciativa requiere integrar gran cantidad de datos, establecer unos indicadores medibles y hacer que esta información sea útil, transparente y abierta a toda la ciudadanía. Esta herramienta permite medir datos sobre biodiversidad, economía e innovación, movilidad, eficiencia energética, servicios sociales y sanitarios municipales. Este es el primer grano de arena para que, con la participación de todos, miremos hacia el futuro en positivo y la Agenda 2030 se abra camino en los ayuntamientos españoles. Caminamos hacia la sostenibilidad. ¿Y tú?
El servei de cita prèvia de la teva administració permet a qualsevol persona ser atesa amb la màxima seguretat, evitant esperes, cues i desplaçaments. Reserva cita en qualsevol moment i lloc des de qualsevol dispositiu connectat a internet per a formular sol·licituds, consultar informació o aclarir qüestions relacionades amb un tràmit ja iniciat. Tot això seguint uns senzills passos. Accedeixi a l'apartat de cita prèvia de la seu electrònica. Seleccioni el servei i agenda en el qual desitja sol·licitar cita. Triï el dia i hora de la cita entre les que estiguin disponibles. T'ofereix la possibilitat de reservar cita per ser atès presencialment per telèfon mitjançant una trucada que rebrà de la seva administració o a través del nou servei d'atenció per videoconferència. Tan aviat com es confirma la cita, s'envia un missatge per correu electrònic amb els detalls d'aquesta. El dia de la cita podràs presentar-te a l'oficina d'atenció al públic, rebre una trucada telefònica o connectar-te per videoconferència amb el servei sol·licitat a l'hora acordada. Un servei de cita prèvia adaptat als nous temps per acostar-te a la teva administració i garantir-te la màxima disponibilitat, seguretat i accessibilitat possible.
Per una gestió senzilla de tots els documents i expedients tramitats per l'entitat, és necessari aplicar un model simple que permeti gestionar el cicle de vida dels documents. Les plataformes d'administració electrònica de Gdpr inclouen un model de gestió documental i arxivística que garanteix el correcte tractament i conservació de tots els documents gestionats per l'entitat. Tant els documents que es capturen a través del registre electrònic de documents i de la seu electrònica de l'entitat, com els que generen el gestor d'expedients i documents, resultat de l'activitat de l'entitat, s'emmagatzemen de forma centralitzada i segura al repositori documental de la plataforma d'administració electrònica, acompanyats de les metadades de preservació i gestió, classificats segons el quadre de classificació documental de l'entitat. Existeixen altres sistemes productors de documents i expedients que emmagatzemen tots els documents que produeixen el repositori documental centralitzat, inclòs a la plataforma d'administració electrònica. Els calendaris de transferència configurats per l'entitat al mòdul d'arxivística de la plataforma d'administració electrònica permeten automatitzar la transferència dels expedients i documents a la plataforma de custòdia i preservació digital utilitzada per l'entitat. Els expedients transferits són conservats a la plataforma de preservació digital fins al moment de la seva destrucció o conservació permanent. Gestiona simple i eficaçment tots els documents i expedients de la teva entitat amb les plataformes d'administració electrònica de Berger Lebro i els seus mòduls d'arxivística.